What's up, guys? It's me, Miss Moncrief, here with a new lesson for you. So today we are looking at more factoring. We love factoring. It's so much fun. So let's remember one of the patterns we had. So we had the difference of square, which is really just the ax squared minus by minus b squared y squared is really ax plus by times ax minus by. Now, you might remember that we didn't have this y squared or these y's at the end the first time, and we did it. But that's going to make more sense to you here in a second. So let's recall factoring these first. Now, remember, in order for it to be a difference of squares, it has to have a few things. First thing, has to have two terms, and only two terms. Please just get rid of that two terms. It has to have only two terms. And then, so let's look at A. Does that only have two terms? Yeah, it has x squared and 36, so we're cool with that. And the next thing, 2, it has to be a minus in the middle. Minus in middle. Middle. Is there a minus in between that x squared and 36? Yeah. And then 3, the two terms must be perfect squares. Terms must be perfect squares. Let me erase this because it's never going to fit there. Perfect squares. So now our x squared and 36 perfect squares. Well, let's check it out. If they're perfect squares, we'll get something nice at the end. And when I say nice, I mean like x, 5, 2, a whole number. So what's the square root of x squared? Well, that is just, x. And then what's the square root of 36? Well, that is just 6. So since this works out, we can do x plus 6 and x, oh my goodness, minus 6. And we got our difference of squares. The difference can stand for the difference and difference of squares can stand for two things I like to tell everybody. The subtraction difference in between the two terms and the different signs in the two binomials at the end. And that one's all factored. So now let's check out B. Does it have two terms? Yep, we're cool with that. Does it have a minus in the middle? Yep, we're cool with that. So now we need to see if these are perfect squares. So let's try to take the square root of 49x squared. Well, what's the square root of 49? Second square root 49. That's 7, so we're cool with that. So we have 7. And then what's the square root of x squared? Well, that's just x. We've done that one a lot. And then we need to see what's the square root of 1. Well, the square root of 1 is just 1. So those are both perfect squares. So we have 7x plus 1 and 7x minus 1. Now let's check out C. See, we have 9x squared minus 81. So first of all, let's go through our list of things. Does it have two terms? Yup, it only has 9x squared and 81. Is there a minus sign in the middle? Yup, there's that minus. And now let's see if they're perfect squares. What's the square root of 9x squared? Well, the square root of 9 is 3, and the square root of x squared is x. So the square root of 9x squared will be 3x. And then what's the square root of 81, everybody? You're right, that is 9. So that means we have 3x plus 9 and 3x minus 9. Alright, and let's check out our, sorry about that, last one, 196x squared minus 144. Well, let's start off. Are there only two terms? Yes, there are. We only have that 196x squared and 144. Is there a minus sign in the middle? Yup. And are these terms perfect squares? Now, I don't know about you, but let's figure out if 196x squared is a perfect square. Remember, we can take the square root, second square root, 196, and we get 14. So we have 14x. So we have 14, and then what's the square root of x squared? X. Very good. And so we got 14x to the square root of 196x squared. And then what's the square root of 144? Well, that would be 12. So we have 14x plus 12, and we have 14x minus 12. And there is our factored form. And yeah, that should have been a good review. We've done that before. We like it. We love it. All right, but now let's try something a little different. And I know I bet you all have been at home wondering, I know I can do this. I can do the difference of squares with one variable, but what if we had two? Like, what if we had an x and a y? I know you've all been sitting there wondering that. I sit there and wonder that in my free time too. So let's look at it. We have difference of squares with two variables and a GCF. With two variables and a GCF. So let's look at example 1a. We have x squared minus 9y squared. So we still want to go with some of these rules. Let's start with, are there only two terms? Yeah, we have x squared and we have 9y squared. There's two terms. It also still needs to have the minus sign in the middle. Do we still have the minus sign in the middle? Yes. Now we want to see if the terms are perfect squared. Perfect squares. Now, is x squared a perfect square? Yes, we've done that one a lot. What's the square root of x squared? Well, that would be just x. So we're cool here. Now let's try to take the square root of 9y squared. Well, we did it earlier when we had 9x squared and 196x squared. What's the square root of 9? We all know that that's 3. And then what's the square root of y? What was the square root of y squared? Well, the square root of x squared was x, so the square root of y squared is going to be y. So that means we have two terms that were perfect squares, and we got the square root of them, so it will be x plus 3y and x minus 3y. And there you go. It's the same thing, but it's just throwing in a new variable. You're not doing any different steps other than still taking the square roots. Now let's look at example 1b. 1b, we have 54a squared minus 6b squared. Now, let's go through our checklist. Is there two terms? Yeah, there's two terms. We have 54a squared and 6b squared. Is there a minus sign in the middle? Yes, we see it. We love it. It's working out. But now are these perfect squares? Well, let's try it. What's the square root of 54? That's not working out. And then what's the square root of 6? That didn't work out either. But let's see if there's a GCF. Is there a number that can go into both 54 and 6? So remember, we can do that by doing 54 divided by x and 6 divided by x. And go to second graph to get to your table. And we want to see which of these x values has has a whole number in both y1 and y2. So 1, yes, they do, but let's see if there's a number 1. We want the highest x value that does. 2 also does, 27 and 3. 3 also does, 4 doesn't, 5 doesn't, 6 does. But the rest of them don't. So we do have a GCF. My GCF is, in fact, that 6 where we have 9 and 1. So let's go ahead and pull out our GCF. So we have 6 times, and then what are 54a squared and 6b squared divided by 6? Well, 54 divided by 6 is 9, so we have 9a squared minus, what's 6b squared divided by 6? 1b squared, or just b squared. Alright, so now that we've factored out our GCF, let's just look at the binomial and see if that one can be factored using our difference of squares. So let's start back over on our checklist. Is there two terms? Yes, we have 9a squared and b squared. Is there a minus sign in the middle? Yep, cool, still working. Now, are these two terms perfect squares? Well, let's check it. What's the square root of 9a squared? We know the square root of 9 is 3. We know the square root of a squared will be a. So yeah, that's a perfect square. Square root of b squared. Well, that's just going to be b. So yeah, it works out. So that means we'll have still our GCF 6 times 3a plus b times 3a minus b. And there you go. You learn how to factor difference of squares with multiple variables and a GCF. Isn't that cool? I think it's cool. You'll think it's cool too. All right, well now let's look at another factoring part. Let's look at more factoring because we love to factor. All right, it says recall completely factoring a trinomial. So remember, a trinomial is fully, completely, or correctly factored when the GCF is factored out and the resulting trinomial cannot be factored any further. So this just means we take the GCF out and then we factor again. It's kind of like what we did here. So let's look at A. We have 4x squared plus 62x minus 32. So let's see if we can find a GCF between those three numbers. So go into your y equals and do them all. Divided by x. Our A is 4, so 4 divided by x. B is 62, so 62 divided by x. And C is 32, so 32. Ooh, why did it go all the way down there? 32 divided by x. Wow, why is it doing everything but on x? So 32 divided by x. And now we want to find the highest x value in our table that has all whole numbers and the rest of the y values. So second graph, what is the highest x that has all whole numbers? 1, 2, might be 2, 3, 4's got a decimal, 5's got a decimal. All right, so it looks as though it's 2. 2 is our GCF, so let's pull out a 2. So remember, when we do this, we're technically dividing all these by 2, but this calculator has our new a, b, and c. A will be in the y1, so 2x squared plus what's b? 31x. And then c would be, don't forget the sign, negative 16. All right, and then now that we've taken out the GCF, we can just continue to factor it, and we can do that by doing our lovely little snowflake method. Yes, we love the snowflake. So remember, ooh, I hate the snowflake already. Remember, this is just putting A, B, and C in different spots. So what goes in the top? A times C. What is A? 2. And what is C? Negative 16. What is 2 times negative 16? Hold on. 2 times negative 16. That gets us negative 32. And then in the bottom we have B, which is 31. And then out to the sides we have AX, which would be 2x. And 2x. Now let's remember how we use our calculator to get numbers that multiply to get us negative 32 and add to get us 31. So we go to y equals, clear everything out because we don't need that anymore, and go to y1. We can do negative 32, the top one, divided by x and y1, and negative 32 divided by x plus x and y2. Go to the table and find your bottom number, your b, and y2. So let's find 31 in y2. Okay. Oh, I passed it. There it is, 31. And we get 32 and negative 1. So now we need to see if any of these will simplify. Can 2x and 32 simplify? Yeah, they can both be divided by 2. What's 2x divided by 2? Nah, that's just x. And then what is 32 divided by 2? Well, that is 16. Can we simplify 2x into negative 1? No. So now we're left with our GCF first, so 2 times this new factor, x plus 16. And then this other factor, 2x minus 1. Alrighty, and that one's completely factored. Now let's check the next one. We have 6x squared minus 10x minus 24. So the first thing we obviously needed to do is figure out if there's a GCF between 6, 10, and 24. You might already know it, good for you, but we're going to check it out. We're going to start with a divided by x, 6 divided by x, 10 divided by x, and 24 divided by x. And do second graph. You're going to go back up and find the highest x value that has all whole numbers. 1 has all whole numbers, 2 has all whole numbers, so we'll keep on the 2. 3 doesn't have all whole numbers. There's a decimal. 4 has 2 decimals. 5 has a decimal. That's 2 decimals. 6 has a decimal. 7 has 3 decimals. All right, so I think it's just 2. Because if you keep going, it won't work out anymore. We have 2. So my GCF here is 2. So we have 2 times, what's my new a? 3. So 3x squared minus, what's my new b? 5x minus, and what's my new c? 21. Oh, not 21. Oops. 12 minus 12. And then from there, we can do our snowflake in order to find our 2 other factors. So remember what goes on the top? A times 3. Oh my gosh, why can't I draw a decent snowflake? Sorry. It still looks ugly. Alright, so remember, in the top we're going to want to do a times c, which means it'll do the first one. First term inside the parentheses, so 3 times negative 12, which will get me negative 36. In the bottom we'll have b, which will be negative 5, and then we'll have ax, which will be 3x on the sides. I think I figured out why it's not writing pretty. So now let's go to y equals and find numbers that will multiply to get us negative 36 and add to get us negative 5. You might already know it. So negative 36 divided by x. That's too many negatives. And negative 5 divided by x. Second graph. And we are again looking for, ooh, wait, I messed up. What messed up? That should be negative 36 divided by x plus x. And we'll go to second graph, and we're going to look for negative 5 and y2. So go down to negative 5, and what do we get? Negative 9 and 4. And just positive 4. Negative 9 and 4. So from there, we can actually start. Now we need to see if we can simplify. So is there anything that can go into both 3x and negative 9? Yes, that'd be 3. So what's 3x divided by 3? Well, that's just x. And now we have negative 9 divided by 3, which will give us negative 3. Is there anything that can go in 3x and 4? Nope. So that means my completely factored form will start with my GCF of 2. And then we'll take my x minus 3. And we will also take my 3x plus 4. And there you go. That is your completely factored form. But again, that was just a review. That's something you should know how to do. And now I bet you're thinking, well, I wondered earlier about what it would be like containing a variable. So I kind of want to know what it's like to have an extra variable in here. Well, let's look at it. We want to take it up a notch in factoring out a GCF containing a variable. So let's look at example 2a. We have 2x to the fourth plus 22x cubed plus 56x squared. So let's see if those have a number in common, which I think we all know that they do. So we have 2 divided by x, 22 divided by x, and 56 divided by x. And we want to see if they have a GCF. So we're going to go in my x values and see which one has the all whole numbers. All right, 2 so far is looking top notch, and 2 is going to be our answer. They're all decimals, and that's gross. So let's go back to 2. So 2, we're going to definitely take out the 2, but what else? Do all of them have an x? Well, this one has 4 x's, this one has 3, and this one has 2. So yeah, they all definitely have at least one x, so we can take an x out. And I'm always just going to say take the lowest amount of x's out. So this has 4, this one has 3, this one has 2. What's the lowest amount of x's? That's 2, so we have x squared. And that's going to help us factor it. So definitely continue getting your a, b, and c from here. So what's your a? So that would be 1, and then divide the x to the fourth by x squared, which would be subtracting the exponent. So it's 4 minus 2. That will give us x squared. Plus, what's my b now? 11. And subtract the exponents. 1 second.
Third lunch, blue, grab and go.
What's 3 minus 2? Will get us 1, so x to the power of 1, or just x. And then lastly, what's your c, which would be 28, so plus 28. And then squared minus 2, which will get you 0, so you have no more x's. All right. So now we have 2x squared times x squared plus 11x plus 28. And remember, all we're doing when we find the lowest amount of x's is subtracting that exponent to find what our new exponent's going to be. So now that we've taken out our extra variable, we can actually just keep factoring it like we normally do. So we're going to do the snowflake. Maybe I'll draw a better snowflake this time. Better, not great. So definitely what's going to go on the top is a times c, so 1 times 28, which is just 28. What's going to go in the bottom is b, which is 11. And what's going to go outside is 1x and 1x. So what's numbers that will multiply to get us 28 and add to get us 11? I don't know. Let's find it in the calculator. And let's hope I do it right this time. So we'll have 28 divided by x and 28 divided by x plus x. And we'll go to second graph, and we need to find 11 and y2, which I think I found it. And there it is. It's 7 and 4. So 7 and 4. And is there anything to simplify in this 1x and 7 and 1x and 4? No, so that means my new completely factored form will start with my GCF, so 2x squared. And we'll do x plus 7 times x plus 4. And there it is, my completely factored form of the quadratic for 2x squared plus 22x, 2x to the fourth plus 22x cubed plus 56x squared. All right, and now we need to try one more. So now we have 6b squared a minus 36ba minus 162a. So first of all, let's see what number they all have in common. We can do that the same way we've been doing it. Each number divided by x. So what's my first number? 6 divided by x. Not x times x. And then we have 36 divided by x. And now we have 162 divided by x. And we can go second And let's see where we can go until we don't have any more. Let's see what's the highest x value that has all whole numbers. So 2, starting at 1, 1 has all whole numbers, 2 has all whole numbers, 3 has all whole numbers, 4 does not have all whole numbers. That's rude. 5 doesn't have all whole numbers, 6 has all whole numbers, so 6 might be promising for a GCF. 7 has decimals, 8 has decimals, 9 has decimals, 10 has decimals, 11 has decimals, and everything after 6 has decimals. So 6 is my highest x value with all whole numbers. So we know that part of my GCF is definitely 6. Now let's see if they have any variables in common. The first term has b squared a, so keep that in mind. The second term has ba, so they both have a b and an a in common. But the last term only has an a, so it doesn't have a b. So that means this one has all a's in common, so we can take the 1a out. So what's my exponent on here? 1 and 1. So we can still do the subtracting the exponent. So let's start with dividing by my GCF. What's my GCF? 6, so that means my new a term is going to be 1, so we have 1. Nothing happened to the b squared, and then we have a, which would cancel out because we took it out. Oh, so 1b squared minus, what's my new b? 2. Right, we took out the a, so 2b, and then minus 162, took out the a, so minus 27, because that was our new c term. Oof. Minus 27. So now we have 6a times 1b squared minus 2b minus 27. And from there we can just factor. So let's go ahead and factor this trinomial, b squared minus 2b minus 27. Oof. I did so well on the last ones. All right, so what goes in the top? That's a times c. So what's a? 1. 1 times negative 27, which is going to give me negative 27. What goes in the bottom? B, which is negative. Oh, shoot. B is actually supposed to be negative 6. I accidentally put 2 instead of 6. That's my bad. This should be 6. So what goes in the bottom? 6, negative 6. And then what goes out to the sides? That would be 1x and 1x. So what are two numbers that will multiply to give me negative 27 and add to give me negative 6? Let's go to our y equals. Clear everything out because we don't need that anymore. And let's do the negative 27 divided by x and 27 divided by x plus x. And go to second graph and find that 6, negative 6 in y2. So far I don't see it, and these numbers are getting bigger, so we're going to want to go in the x column and go up until we see it. Ah, there she is, and my two numbers are 3 and negative 9. And is there anything I can simplify between the 1x and the 3 and the 1x and the negative 9? Nope, so we're good. So start your factored form with the GCF, which would be 6a, and then move into these other two. So x plus 3 times x minus 9. And there is your completely factored form. But wait, something else I've messed up on was, what variable are we using? B. So all of these should not be x, they should be b. Don't forget to check your variable, kids. It's important. This should be 1b and 1b. So you really have 6a times b plus 3 times b minus 9. And there you go. All right. now that we've gone through a couple of newish stuff, really just adding on to stuff we've already learned, let's go into looking at something like that's almost completely new. We want to simplify. We are simplifying rational expressions by factoring, or something new to do with factoring. So we're simplifying rational expressions now. So we are looking at c squared minus 25 over c squared plus 5c. So when we're simplifying rational expressions, the first thing we want to do is just factor the numerator and the denominator. So we want to factor both the top and the bottom of the fraction, and then we'll move on. So let's look at c squared minus 25. Well, that looks pretty peculiar to me. It kind of looks like this difference of squares at the top. So let's see it. Does it have two terms? Yep. Does it have a minus in the middle? Yep. Well, let's see. Are these perfect squares? What's the square root of c squared? Well, that's just c. What's the square root of 25? Well, that's just 5. So that means my new factored form is going to be c minus 5 times c plus 5. And we're cool there. Now let's look at the denominator. We have c squared plus 5c. Now you might be thinking, is that a difference of squares? Well, let's go through it. Does it have two terms? Yep. Does it have a minus sign in the middle? No, so it's not a difference of squares. But let's see if they have anything else in common that we can factor out. I don't see anything except for the fact that they both have a c. So we can factor out that c, which means we'll end up dividing them both by a c. So what's c squared divided by c? Well, that's just c. And what's 5c divided by c? Well, that's just 5. So we'll have c times c plus 5. And after we've factored the numerator and the denominator, we will simplify the fraction by canceling terms. And that just means if you see a binomial, or that means if you just see anything that's the same on the top and the bottom of the fraction, you'll cancel them out. So we have a c minus 5 on top. Do you have a c minus 5 on bottom? No. We have a c plus 5 on top. Do we have a c plus 5 on bottom? No. Yeah, we do. So since we have both, we'll cancel them out. And we have a c down here. Do we have just a c alone on top? No, the c is connected to the c at the top is connected to c minus 5, so we can't cancel those out. So that means we're left with c minus 5 all over c. And that's just our answer. That is our simplified rational form of a fraction. That is our simplified rational expression. Is c minus 5 over c. And we can't cancel these c's out because at the top there's a minus sign in between them. So it won't work out. All right, now let's look at example 3a. The first one, we have 25x squared minus 4 divided by 5x squared minus 2x. So let's start with the top. I have 25x squared minus 4. Well, that's starting to look to me like a difference of squares. Let's see if that works out. Was there two terms? Yep. Is there a minus sign in the middle? Yep. Are these both perfect squares? Let's see. What's the square root of 25x squared? Well, that's just 5x. And what's the square root of 4? Well, that's just 2. So my top one is a difference of squares, so it can be 5x plus 2 times 5x minus 2. Now let's see if we can factor the denominator. We have 5x squared minus 2x, all right? This isn't a difference of squares because these are not perfect squares. But do they both have something else in common? Yeah, they both have an x in common, so we can divide both of them by x. So 5x squared which means we have a GCF of x. We have x out here, and we have 5x squared divided by x, which is really just 5x. Minus, and we have 2x divided by x, which is just 2. So now let's see what we have in common. Alright, I have a 5x minus 2 in the top, and I have a 5x minus 2 in the bottom, so those cancel out. So that means I'm left with 5x plus 2 over x. Oops. Over x. And there we go. We have 5x plus 2 over x. And that is my simplified rational expression. All right, let's do one more. We now have x. Ooh, why did I do that? We now have x squared plus 7x plus 10 and x squared minus 3x minus 10. So first of all, neither of these are difference of squares. So that's super annoying. I think the best can't factor them any other way than snowflakes. So let's snowflake them. Let's start with the numerator. So what's going to go on the top? 1 times 10, which is just 10. And then the bottom will have 7 and 1x. And 1x. What are numbers that will multiply to get me 10 and add to get me 7? Those would be 5 and 2. Again, you can put in the calculator to figure that out. And my numerator factored out is going to be x plus 5 times x plus 2. All right, and now let's factor out the denominator. Well, x squared minus 3x minus 10. That one, I think, again, is just going to be best to factor it using the snowflake. There's no special pattern there. Oh my gosh. So in the top, we're going to have our a times c, which would be 1 times negative 10, so negative 10. In the bottom, we'll have b, negative 3. On the sides, we'll have x, 1x, and 1x. So what are numbers that will multiply to get us negative 10 and add to get us 3? Well, that's going to be negative 5 and 2. So that means my terms are x minus 5 and x plus 2. 5 times x plus 2. And now we can check to see which ones will cancel out. Well, we'll just have to cancel out the x plus 2. So we have x plus 5 over x minus 5. And again, none of these can be canceled out because they're separated by plus or minus signs. These were all separated by multiplication, which made it work. But now that we're stuck to just addition, it's not, there's addition and subtraction, you can't cancel it. So my final answer is x plus 5 divided by x minus 5. All right, and that is the end of today's lesson. If you have any further questions, you can go message your teacher. I'm sure she would love to help you. So yeah, I hope you have an absolutely lovely day.